Anybody faced any problem?
Sir, now it's okay, sir.
Yeah. I have already authorized you. So anybody faced any problem regarding data management? Nobody? Faisal is here. I have seen Faisal. Okay. Dr. Shoibal, do you hear me? Dr. Shoibal?
Is everywhere. So think about
Sir, আমার এখানে একটু আওয়াজ হচ্ছে ব্যাকগ্রাউন্ডে স্যার। I can hear you, sir.
Okay, fine. Puno, did you face any problem?
না স্যার, আমি কোনো প্রবলেম ফেস করিনি স্যার। আমি আবার ইয়েগুলি রিপিট করেছি স্যার। মানে আমার কোনো, আমি বই ইনস্ট্রাকশন পড়েছি, চ্যাপ্টার 6 পড়েছি স্যার।
ওকে, বইটা দেখে করা যায়, করতে পারেন?
হ্যাঁ স্যার, করা যায় স্যার।
ওকে, আলহামদুলিল্লাহ, তাহলে কোনো অসুবিধা নাই। So that's very good. Then Dr. Uma.
Assalamu alaikum, sir.
Alaikum salam. Dr. Uma. Dr. Uma. Okay. Snigdha, apni kono, did you face any problem?
No, sir.
করতে পেরেছেন আপনি গত ক্লাসে আমরা যেগুলো করেছি?
জি স্যার।
Okay, very good. Then Asma, Dr. Asma Firdausi.
স্যার।
জি, আসসালামু আলাইকুম।
আমি স্যার নিজের মতো চেষ্টা করিনি স্যার, আমি আসলে বলতে পারবো না, ইনশাআল্লাহ পারবো সামনে ইনশাআল্লাহ।
ওকে, পারবেন, ভুল না করলেও বই দেখে আশা করি করতে পারবেন। ঠিক আছে? Yeah, looking at the book, hope that you can do all the data management issues that I have discussed. So let me start. Please open the SPSS program and read the data file 3. Open the SPSS program and read data file 3. Let me share the screen. So have you opened SPSS and read the data file 3? Have you opened SPSS?
Yes, sir.
Okay. So in the last class, what I could not discuss is sometimes you may need to analyze your data for a particular group of people. In our language, we call it subgroup analysis. Okay, for example, suppose in our data, we can see there is a variable religion. In the variable religion, we have Muslims, Hindus, and Christians. Suppose you want to analyze your data only for the Muslims. Okay, have you got my point? I want to analyze the data only for those who are Muslims. I don't want to include other two categories in the analysis. in SPSS, we can do it. And it is called subgroup analysis. It is like this. You may also want to analyze your data only for those who are males, like this. You can also select like this. Suppose I want to analyze my data only for those who are more than 20 years old, okay? So in SPSS, we can do that. So first of all, let us see if we want to analyze our data only for the Muslims. So in that case, we shall have to check the code number of Muslims. So we can see that the code number of Muslim is 1. Can you see my screen?
Yes, sir. Yes, sir.
Okay. In that case, what we shall do is that we shall tell SPSS to select religion if it is equal to 1. Okay? To select religion, because religion 2 is our variable name. We shall instruct the SPSS to select religion 2 if it is equal to 1. So go to data. Click on data. Then come to select cases. Select cases. Select cases. Select cases. Click on select cases. Click on this. Done. Done. So I'm clicking on select cases. So I am in this dialog box. Can you see it?
Yes, sir.
Okay. Now, under select, let us select if condition is satisfied. Now, all cases are selected. You can see that this is called the radio button, okay? So we can see that the radio button of all cases is highlighted. Now we shall select if condition is satisfied. So select this one. If condition is satisfied. Have you done it?
Yes, sir.
Okay, now click on if. Click on if. Click on if. Have you done it? Done.
Yes, sir.
So click on if, okay? Now we shall select the variable religion from here and push it into the empty box on the right-hand side. Okay, select religion, push it into this empty box. Done. Done.
Yes, sir.
Okay, then click on equal to from here. Click on equal to this one. Click on equal to. Equal to. Done, so I have clicked. Equal to, what was the code number for religion? It was 1. Equal to, then click on 1. Okay.
Okay, sir.
Okay, so you can see that at the top, select cases if religion is equal to 1. Okay, can you see it here? You can see that select cases if religion is equal to 1. Then continue, okay. Continue, okay. Continue, continue, then okay. Continue, then okay, okay. Continue, okay, fine. Have you done it? Now let us go to data view. Let us see what has happened. Okay, come here, then go to data view. Are you in the data view now?
Yes, sir.
Okay, you can see that some of the numbers are crossed. Okay, that means these are the subjects which will be excluded from further analysis. Okay, for example, say if you click here, you can see, you see the Hindu, 2 is Hindu, it is excluded. Okay, click on this icon, in this icon, this one. Click in this icon, value level icon. Okay, click in this icon. Have you done it? Just, huh? So
Yes,
that,
sir.
so you can see that, you see the Hindu is excluded. Here again, Hindu is excluded. You can also see that, you see the Christian, it is also excluded. Okay. Now, if you do any analysis, you will see that the analysis includes only the Muslims, nobody else. For example, if we make a frequency distribution of occupation, of religion, what do we expect to see? If we want to make a frequency distribution of religion, what do we expect to see? We will see only Muslims. Okay, we will not see Hindus and Christians. So can you make a frequency distribution of religion? Analyze, descriptive, statistics, frequency. Okay, then religion. Religion, okay. Okay, so you can see, you see only the Muslims are there and there are 126 subjects. Okay, have you got it? Have you got it? Is it okay?
Yes, sir.
Okay. So if you want to do a subgroup analysis, you can do it like this. First of all, we shall have to select the specific group. If you want to select the subjects who are more than 20 years of age, the process is same. Say go to data, then select cases, reset it, reset, then select if condition is satisfied, click on if, click on if, now select age, age we said more than, so click more than, now write 20, okay? So age more than 20, okay? Fine, then continue, okay. then continue. Okay. Now the subjects or the respondents who are more than 20 years of age will be included in the analysis. Am I clear?
Yes, sir.
Okay. So now if we do any analysis, for example, now if I make a frequency distribution of, say, religion, you will see that there are 160 subjects. But in our data, we have seen earlier that there are 210 subjects. We have only 160 subjects because 50% are aged less than or equal to 20 years. Okay. You can also check the data view. You will see that the persons who are aged less than 20 are excluded from analysis. For example, number 4, you can see the age is 18 years. Number 6, age is 12 years. Okay, that's why they will be excluded from the analysis. Okay. Am I clear?
Yes, sir.
Now, if we want to analyze the data for all the subjects, then again, we shall have to go to data, select cases, just select all the cases. Okay, select all the cases, then okay. Then again, we shall be able to analyze the data for all the subjects. Clear? Clear?
Yes, sir.
Okay. Suppose we have selected the subgroup if age is more than 20. You can also save this file, that is in another file, so that all the subjects will have more than 20 years of age. Okay, you can also do this. To do this, you see like this, copy selected cases to a new file. So if you write a file name, the computer will save the data set only for those who are aged more than 20 years. Okay, but don't do this. Okay, am I clear?
Yes, sir.
Huh? Am I clear?
Yes, yes, yes. Yes, sir.
Okay, okay, fine. We don't need it actually. So let us select all the cases. All the cases, okay? Select all the cases. Okay. Oh, I see. Data, select cases, all the cases, okay? Okay. Now, today we shall discuss hypothesis testing. We shall discuss about hypothesis testing. Okay?
স্যার আমার একটা
তো-
কোয়েশ্চেন আছে
হ্যাঁ, বলেন।
স্যার গত ক্লাসে যে আমরা ডায়াস্টোলিক হাইপারটেনশনের জন্য হচ্ছে মোর দেন 90 তে মেল এবং মোর দেন 85 এ ফিমেলে যেভাবে বের করছিলাম ডায়াস্টোলিক হাইপারটেনশন, ওইটা কি স্যার এইভাবে বের করা যাবে যে ডাটাতে যে সিলেক্ট কেসেস?
না, ওইভাবে ভালো হবে না। আপনার তো দুইটাই লাগবে। ইউ নিড বোথ। How many people have the diastolic blood pressure more than this? How many people less than? But if you want to select only those who have hypertension, that you can do. Okay. If you
Yes,
want
sir.
to select those group, that you can.
মানে আমি যদি শুধু আলাদা করে মেইলেরটা বের করতে চাই তাহলে আমি এভাবে বের করতে পারবো।
হ্যাঁ।
আচ্ছা, এইটা বেশি ইজিয়ার মনে হয়েছে ওইটার থেকে, এই জন্য
Okay.
জিজ্ঞাসা করলাম।
Okay, অসুবিধা নেই, no problem.
Okay,
Now
sir, thank you.
let us discuss about hypothesis testing. Okay. Frequently for our studies, we need to test hypothesis. Whenever our studies have the objective like we want to find association between this and that, it indicates that we need to do something to test the hypothesis. For testing hypothesis, we have different kinds of statistical methods. But the statistical methods that we need to use depends on several factors. Okay? Before that, let us see what is hypothesis, what are the types of hypothesis. Hypothesis is, remember that hypothesis is always concerned about the population. It means that we conduct the studies taking a sample from the population. Even though we are taking sample from the population, actually our objective is to understand the population value. What is the value in the population? That is our primary objective. Therefore, hypothesis is concerned about the population values, about the population, okay? Hypothesis literally is a statement about one or more populations. Hypothesis indicates what do we assume in our population. For example, suppose you have conducted a study to determine whether smoking is associated with asthma or not. If we want to test this hypothesis, whether there is an association between smoking and asthma, actually indirectly it means that the people who smoke, what proportion of them are suffering from asthma? Means what percentage? Proportion means percentage of the smokers have asthma compared to those who do not smoke. Okay. Actually, we shall compare what percentage of smokers have asthma compared to those who do not smoke. Okay. Suppose we have conducted a study and we have selected 200 subjects from a community randomly. And we found that say 10% of smokers have asthma, while say 7% of the non-smokers have asthma. Okay. Now, since we have taken a sample, now the question is whether in the population means if we could collect data from the whole population, whether this percentage would be same or not. Okay, am I clear?
Yes, sir.
Okay, so hypothesis is a statement, as I said, about one or more populations. Hypothesis is of two types. One is null hypothesis, another is called alternative hypothesis. Null hypothesis and alternative hypothesis. Remember that null hypothesis is the hypothesis of equality. Null hypothesis always says that two or more quantities are equal. For example, as I said earlier, if the null hypothesis, if we write null hypothesis, then my null hypothesis will say that the prevalence of a smoker, prevalence means a percentage of smokers who have asthma is equal to the percentage of non-smokers who have asthma. That would be the null hypothesis. So null hypothesis always says that the groups are equal, the groups are same. Clear?
Okay, sir.
And the alternative hypothesis says that no, the groups are not the same, they are different. The percentage of asthma among smokers and non-smokers in the population is not same, is different. Okay, that is the alternative hypothesis. So you can see that the null hypothesis is the hypothesis of no difference or equality. It will always say they are equal, they are same. While the alternative hypothesis says that these two are, okay. The alternative hypothesis will say that the quantities are not the same. Remember that statistically, we test the null hypothesis, not the alternative hypothesis. So it is important to remember, statistically, we test the null hypothesis, not the alternative hypothesis. If we can reject the null hypothesis, then only we can say that alternative hypothesis is true. But if we cannot reject the null hypothesis, then the null hypothesis remains true. We cannot accept the alternative hypothesis. Okay, am I clear?
Yes, sir.
Am I clear? Okay.
Yes, sir.
For hypothesis testing, we use some statistics and we call them inferential statistics. Inferential statistics. We use for testing the hypothesis. Okay, we use inferential statistics for testing the hypothesis. That means the statistics that we use for testing the hypothesis are called inferential statistics. Okay, clear?
Yes, sir.
Okay. If we use inferential statistics, the computer will provide you the p-value. Will provide you the p-value. Okay. If we use inferential statistics, the computer will provide you the p-value. Okay, clear?
Yes, sir.
If the p-value in general, if the p-value is less than 0.05, we shall reject the null hypothesis. Okay? So remember this p-value. If it is less than 0.05, we shall reject the null hypothesis. If the p-value is greater than 0.05, we cannot reject the null hypothesis. Clear?
Yes, sir, but what is the meaning of P?
Therefore, while we shall be doing hypothesis testing, commonly our interest is in the p-value. We want to see what is the p-value. Okay? That is our primary interest. Okay? In SPSS, the p-value is indicated by SIG, S-I-G. SIG means significance, okay? In SPSS, the p-value is indicated by SIG. Okay, is it all right?
Yes, sir.
Fine, very good. Okay.
Sir, what
Yes.
is stands for P? Hello?
P-value. Okay, P actually indicates the probability.
Oh,
P-value indicates the probability of rejecting null hypothesis. Let me write it for you.
okay, sir.
Let me write it for you. P-value indicates the probability of rejecting the null hypothesis when it is true. Very difficult to understand it, okay? I will tell you, I will explain it to you later on. Just for time being, remember that the p-value indicates the probability of rejecting the null hypothesis when it is true. When it is true. Okay?
Yes, sir. Thank you.
Okay, fine. No problem. If you have any other question, please feel free to ask. Fine. So now, so we have just seen up to this. Fine. Next, the thing is that commonly, remember that for hypothesis testing, we need comparison group, okay, always. For hypothesis testing, we always need a comparison group. Therefore, in hypothesis testing, commonly, at least there are two variables involved in the analysis. Clear? In hypothesis testing, we need a comparison group. Therefore, in hypothesis testing, commonly, there are at least two variables involved in the analysis of hypothesis testing. It may involve more than two, okay? Clear?
Yes, please.
So in statistical analysis, where two variables are involved, we call it bivariate analysis. Okay, we call it bivariate analysis. So when two variables are involved in the analysis, two to when two variables are involved in the analysis, we call it bivariate analysis. Okay?
Okay, sir.
Bivariate analysis. Now, we have already learned that broadly we can classify. Okay, before that, okay, fine. Now the question is, as I have mentioned, for hypothesis testing, there are many statistical tests available. The challenge is, which statistical test should I use for my data? This is one issue. What statistic shall I use for hypothesis testing of my hypothesis or my data? So the statistics that need to be used depends on several factors. Most important factor is the nature of the variable. What is the nature of the variables involved in the analysis? Whether in the analysis we have involved categorical variables or quantitative variables. Okay, so this is one thing. Second thing is that if we include quantitative variable in the analysis, then the question is whether the distribution of the variable is normal or not. If the distribution is normal, then we use one kind of statistics. And if the distribution is non-normal, then we use another type of statistics. Okay, am I clear up to here? These are the two important issues. One is, what is the nature of the variable or type of the variable we are going to include in the hypothesis testing. Second is, if in hypothesis testing we include a quantitative variable, then the question is whether the variable is normally distributed or not. If it is normally distributed, we shall use one kind of statistics. And if the distribution is not normal, then we shall use another type of statistics. Okay? If distribution is normal, the type of statistics that we use are in general called the parametric methods. We shall see later on. And for the non-normal data, the type of statistic that we use are called the non-parametric methods. So parametric methods and non-parametric methods. Parametric methods are for the data if it is normally distributed, while the non-parametric method is used when the quantitative variable is non-normal. Clear so far?
Yes, sir.
Okay. It also depends on the measurement scale. The type of statistic that we shall use sometimes also depends on the measurement scale. Earlier, I have said that there are 4 levels of measurement. One is called nominal, ordinal, interval, and ratio scale. A variable can be measured either of these 4 types. Nominal scale are the scales, nominal, ordinal, okay? These two are the categorical variables. Nominal scale and ordinal scales are categorical variables. Nominal scale of measurement are the measurements when the variable cannot be arranged into any order. Okay, we cannot arrange the variable into an order. For example, religion. Okay, we cannot order them. Okay, we cannot say that Hindu will be coming first, Muslim will be second, Christian would be third. We cannot say that. Okay, similarly, gender, male, female, we cannot say that. Okay, we cannot arrange that. Then color of your dress, we cannot arrange them. Okay, so such kind of variables are called nominal variables. Next is ordinal variables or ordinal scale of measurement. The ordinal variables are those that can be arranged according to an order, either ascending order or descending order. For example, type of stage of cancer, stage 1, stage 2, stage 3. Severity of pain, mild, moderate, severe. Severity of anemia. So we can arrange them according to order. Interval scale and ratio scales are the quantitative variables. Interval scale are the scales where zero does not have any meaning. Okay, therefore we say that there is no true zero. Actually, zero is arbitrary and it does not have any meaning. For example, temperature. If the temperature is 0, it does not indicate that there is no temperature. Okay. If I give an IQ test and if I scored 0, it does not mean that I don't have any IQ. If I take a math test and if I get 0, it does not mean that I do not know any maths, okay? Like this. Ratio scale is called the highest level of measurement. In ratio scale, there is a meaningful 0. For example, body weight, your age, income, blood pressure, blood sugar, etc. Okay, so what type of statistics we shall use sometimes depend on the variable and how the variables are measured. Okay, clear?
Yes, sir.
It also depends on your study objectives. For example, say if you want to measure the probability of survival, which we commonly use for what should I say, for the studies of prognosis. For example, say if I say that if a cancer patient, say colonic cancer patient, if he receives an anti-cancer drug, what is the probability that the person will survive more than 5 years? Okay, so study objective is like this. In that case, we shall have to select a very specific type of analysis. We use survival analysis, okay? But if we want to simply know that what is the incidence of death within 5 years among the cancer patients, then we may use other statistics, okay? It also depends on the study design. For example, for a case control study, you cannot calculate the relative risk. Okay, we have to calculate the odds ratio like this. Primarily, these 3 points. Actually, what type of statistical test shall we use for testing the hypothesis is mainly depends on these 3 factors. Okay, we shall discuss. Fine. Now we have learned earlier that we can classify a variable broadly into categorical variable and quantitative variable. Correct? Do you remember? We can classify the variables broadly into categorical and quantitative variable. Okay? So if we make a combination of these 2 variables, so what could be the combination? Both are categorical variable, right? Second combination, both can be categorical variable. There can be a combination of a categorical variable and a quantitative variable, and there can be a combination of quantitative and quantitative variable. Correct?
Yes, sir.
So we said that in an analysis, when 2 variables are involved, we call it bivariate analysis. So in bivariate analysis, there may have a categorical variable and a quantitative variable. Okay? There can have a categorical variable, there can have, I mean, both the variables can be categorical, okay? Or it can be like both the variables are quantitative variables. Clear?
Yes, sir.
Now let us see, for example, say it can be a combination like this. Say categorical variable for analysis is sex and quantitative variable in the analysis is age. Okay, can it be like this?
Yes, sir.
So 2 categorical variables, say sex, diabetes mellitus, okay, DM, diabetes mellitus, like this. And it can be a combination of 2 quantitative variables like systolic blood pressure, SBP, and diastolic blood pressure, right? Diastolic blood pressure like this, okay? Now we shall discuss what kind of statistics shall we use to test the hypothesis when we will include a categorical variable and a quantitative variable in the analysis, okay? What type of statistics shall we use to test the hypothesis where in the analysis we shall include a quantitative variable and a categorical variable? Clear?
Yes, sir.
Okay. So we shall see how to find association between a categorical variable and a quantitative variable. Okay. And we said that whenever in our data or whenever we include a quantitative variable in the analysis, we have to know whether this quantitative variable is normally distributed or not. As I have mentioned a little bit earlier, okay? So if this quantitative variable is normally distributed, then we shall use the statistics listed under the normal. Okay? Clear?
Yes, sir.
Okay. If the quantitative variable is not normally distributed, then we shall use the statistics listed under non-normal column. Okay? Now let me explain. Say if we include a categorical variable in the analysis, a categorical variable may have two levels, okay? May have two levels, or it may have more than two levels. So the categorical variables that have two levels in our data is sex. Sex have two levels. Sex has two levels, right?
Yes, sir.
Sex has two levels. Like, okay, please excuse me if there are spelling mistakes, okay? So sex has two levels, like male and female. So in our data, we have variables which have more than two levels. Can you give an example?
Religion.
Religion, okay. Occupation, okay. So these variables have more than two categories or two levels. Okay, so just remember it. Now let us come back. Now in the analysis, if we have a categorical variable with two levels, okay? And another is a quantitative variable, it is fixed. So if the categorical variable has two levels, then we shall use the independent samples t-test, okay? For example, we want to test the hypothesis whether mean age of males and females is same or not, okay? So there are two variables, one is age, another is sex. Sex has two categories or two levels, and our quantitative variable is age. If age is normally distributed, we shall use independent samples t-test. If it is not normally distributed, we shall use the Mann-Whitney U-test. For time being, forget these non-parametric methods. Let us assume that the quantitative variables that we shall be using in the analysis are normally distributed. Okay, let us assume this. Okay, am I clear?
Yes, sir. Yes, sir.
So the question is, when we have one quantitative variable, our interest is to understand the mean. And if we have another categorical variable, naturally, we are interested to know whether the mean of the quantitative variable is same in all the categories or not. Therefore, suppose if we include two variables in an analysis, say one is sex, another is age. In that case, our null hypothesis would be the mean age among males is equal to the mean age among females. Clear?
Mm-hmm.
An alternative hypothesis would be the mean age of males and females are not the same in the population, of course. Okay, am I clear?
Yes, sir.
Okay, however, if there is a categorical variable and a quantitative variable, and if the number of categories in the categorical variable is more than 2, we call it more than 2 levels, then we cannot use this independent samples t-test. We shall have to use ANOVA. Clear? So you can see the difference. If in an analysis where there is a quantitative variable and a categorical variable, and if the categorical variable has 2 levels, we shall use the t-test. And if the categorical variable has more than 2 levels, we shall use ANOVA. Clear?
Yes, sir.
Yes, sir.
Clear? Okay, very good. Then another situation, we can have actually a categorical variable, another quantitative variable, but measured on the same subject before and after. For example, suppose if I want to understand if, say, drug A, any drug, okay? Suppose, what should I say? Say, Indera reduces the heart rate or not, okay? Or let us give another example. Suppose there is a drug which is said to be, which is said to reduce the blood sugar level. For example, say sulfonamide, okay, metformin, okay? Say it's a drug, metformin, it is said to reduce the blood sugar level. Now you want to test whether it actually reduces the blood sugar level or not. To do this, you can do an experiment. So what you can do is that, for example, you have selected a group of individuals randomly from a population. For example, say you have selected 15 persons randomly, and you check their blood sugar level before giving the drug, okay? Then give the drug, and after 1 hour, again check their blood sugar level. So what we are doing, we are collecting data on the same individuals in 2 separate settings. One is before, one is after, okay? Am I clear?
Yes,
This is what in statistics is called related sample, okay? This is what in statistics we call related sample. It is like this. In training programs, we commonly take pre-test, and after the training, we take another test. We call it post-test, but on the same individuals, okay? If our data is like this, then we shall have to use the paired t-test, Clear?
Yes.
Okay.
So what
Yes.
is the meaning, or what stands for T? And ANOVA has a full form as well. ANOVA has a full form as well.
So what is the?
The T means what? Like P was a probability. T means what, sir?
Okay. T actually does not have any meaning. The somebody, you see, for example, in statistics, you will see there are several types of distribution. One is called Z distribution. Why it is called Z distribution, I do not know. And I have never seen it is said anywhere.
Okay, sir.
And they also say it is T distribution, okay?
Okay, sir.
There is also other distributions like F distribution. In ANOVA, actually they are using F distribution. But what does T, Z, or F indicate? I have never seen even in any textbook.
Okay, sir.
Okay.
Okay, sir.
Okay.
ANOVA has a full form or is the name? ANOV.
Which one? Sorry.
ANOVA. Is it a full form or it has a like?
No. It is the abbreviation. ANOVA means analysis of variance.
Okay, thank you, sir.
Analysis of variance. Okay. And ANOVA or analysis of variance are of several types. One is one-way analysis of variance, two-way analysis of variance, then repeated measures ANOVA, analysis of variance, and there is also MANOVA. Okay.
Oh my God.
Yes. Forget about those things. We don't need so many things. Okay.
I know. Sir.
Okay. So remember, these are the commonly used tests. If you go through the literature or if you go through the journal publications, you will see that commonly people are using this one, independent samples t-test. Sometimes they simply call it t-test. Okay?
Yes, sir.
Yeah, simply call it t-test. They don't say independent samples. Okay? But if they use the paired t-test, of course, the sample has to be related sample before and after. This is called related sample. We also call it related sample if it is a matched pair, okay? Sometimes we collect data matching with another variable. For example, a matched case control study. So for time being, forget those things, then it would be very complicated for you. Okay?
Yes, sir.
Okay, let us try to remain with the very simple things. Fine. So, fine. Okay. So let us stop up to here theoretically, because we shall see how to use this test in SPSS and interpret the results today. Okay? Fine.
Yes, sir.
Now, today, we shall test the hypothesis. This one. Okay. So we shall test a hypothesis. Number one, whether mean age of diabetic and non-diabetic patients mean age is same. Okay, so this is one we shall test. We shall also test whether the mean income in all the religious groups is same. Not. Okay, this is 3. And we shall also say whether a training program is effective or not. Okay, we shall check this. Assume that our quantitative variable is normally distributed. Okay, we shall assume it. And we have already discussed how to check whether the data has come from a normally distributed population or not. Do you remember?
Yes, sir.
Okay. So what we did, we said that First of all, we shall check the histogram. Then, if necessary, we shall use the normality test, formal statistical test, like Shapiro-Wilk test. Okay? So we have already discussed. So we shall understand. So before doing these tests, we shall have to actually check whether the quantitative variable is normally distributed or not using those methods. Okay? Check, construct a histogram and do the formal statistical test. Okay. Now, if I want to do this, number one, so what statistic shall I use? Number one, whether mean age of diabetic and non-diabetic patients is same or not. What is statistic? Okay. If you since there are several t-tests, so I think for you, if you specify it, it is better. Which t-test shall we use?
Independent t-test.
Independent, okay. Independent samples t-test, okay? Independent samples t-test. What statistic shall we use for the second one?
ANOVA.
Yes, ANOVA, especially one-way ANOVA, okay? One-way ANOVA. Why we shall use one-way ANOVA? Why we shall use ANOVA?
Because the variable number of groups are more than two.
More than two. Yes.
Very good. Since our categorical variable has more than two categories. Okay, fine. And we shall use one-way ANOVA. In one-way ANOVA, we have only one categorical variable. That's why we shall use one-way ANOVA. Okay. In one-way ANOVA, there is only one categorical variable. That's why. So, which test shall we use for the third one?
Paired t-test.
Paired samples t-test or paired t-test. Paired t-test. Okay. So you know how to decide now. What shall I do? This is very important because after collecting data, most of the people actually does not know which test should they use to analyze their data, or which statistic should they use to test the hypothesis. That's why decision making is very important. Okay?
Yes, sir.
Yes, sir.
Okay, all these things are written in chapter 7.
Yes.
Chapter 7, testing of hypothesis. I have given a table including the examples. So once I finish today's session, and if you go through the table, hope you will understand it. Okay? Okay, fine.
Yes, sir.
Now let us see how to do the independent samples t-test. Okay? And we shall check whether the mean age of diabetic and non-diabetic patients is same or not. So we have two variables. One is age, another is having diabetes. Okay. Another is having diabetes. So go to SPSS. Okay. Now come to analyze. Analyze. Click on analyze. Okay. Okay. What we shall do, we shall compare means. So come to compare means. Come to compare means. Okay.
Yes, sir.
So you can see The SPSS has given all the options. You see, independent samples t-test. There is also paired samples t-test. There is also one-way ANOVA. You see, everything is there. You will just select. Okay? So
Yes, sir.
we shall do the independent samples t-test. So click on this. Click on this independent samples t-test. Click. Done. Click. So now we shall have to select the quantitative variable, which is actually the test variable. Select the quantitative variable, which is age, okay, and push it into the test variables box, okay? So push it into the text variables box, okay? So what is the other variable? Diabetes.
Diabetes.
Diabetes. So select diabetes, select diabetes and push it into the grouping variable box. Okay? Grouping variable box.
Yes, sir.
Okay. Before doing the t-test, you say we shall have to check what are the code numbers for diabetes. You see, that's why I said that if you develop a code book and if you print it out, you can quickly check it, okay? So we can see that diabetes is coded as 1 equal to yes, 2 equal to no, right? Right?
Yes, sir.
Okay, fine. Because we need these code numbers. Now click on define groups. Click on define groups. Click on this. Okay, click on this. Okay. Now group 1 and group 2. So here we shall have to put the code numbers. You can write 1. You can write 2. In the group 1, you can write 1. In the group 2, you can write 2. Or you can also revise it. You can write 2 in group 1. You can write 1 in group 2. Does not matter. Okay? Okay? Only difference is that in our data, code number 1 is those who have diabetes, right? And code number 2 are those who do not have diabetes. Okay. So if you want to compare the age between diabetics and non-diabetics, then put 1 and 2. But if you want to compare non-diabetic and diabetic, then put it 2 and 1. However, whatever the way you place the code numbers, statistics will remain the same, except only one thing. I will tell you later. Okay? Am I clear? Am I clear?
Yes, sir.
Okay, continue then. Okay, you don't need to do anything else. Continue, okay. Okay. Okay, fine. So, have you got the results?
Yes, sir.
So you can see that in the first table, the computer has given, you see this is age and this is have diabetes. That means the number of people who have diabetes is 45 and those who do not have diabetes is 165. The mean age of diabetic patients is 27.9 while the mean age of non-diabetic patients is 26.1. Okay?
Yes, sir.
So this is the standard deviation. Okay, so you can see the mean age of the diabetic and non-diabetic patients, including the standard deviations, correct?
Yes, sir.
So this is the main table that the computer has tested the hypothesis, Okay, one of the assumptions for the t-test is that, do you remember what is variance? What is variance? Variance is when we square the standard deviation, it is the variance, okay? Say 8.4 is the standard deviation here. If you square 8.4, the value that you will be getting will be the variance of age for those who have diabetes. Clear? Variance is equal to standard deviation square. Okay, standard deviation square. How to do the square? Okay, do you understand the standard deviation into standard deviation? Okay. Okay,
that will be 64. That will be 64 in this case.
64 something, correct.
Yes, sir. Yeah, 64.
Okay. That is called
7.4. Yeah.
Okay. That is called variance. So one of the assumptions for the t-test is that the variances of these two groups, that means who have diabetes and who do not have diabetes, are equal. Okay?
Yes, sir.
Variances are equal. Okay? So this is one of the assumptions. Okay, am I clear?
Mm-hmm.
Now the question is, how shall you know whether the variances are same in the population or not? Okay, so it's a question, how will you understand it, right? Okay. Am I clear?
Yes, sir.
Is it all right?
Yes, sir. Could you please repeat? There's a lot of background noise.
Oh, yes, okay, please. Mic gulo ekটু mute korben. So have you got it? What did I say?
Please repeat the last comment, please.
Last comment, yes, sir.
Whether, so what I'm telling is that whether the variance of age among those who have diabetes and who do not have diabetes is same in the population or not. Okay? In t-test, we need to have the variances same. Okay? Am I clear? Huh? Now the question is, how shall we understand whether they are same or not? That was my question. Okay. Are you with me, everybody?
Yes, sir.
Okay. So if we look at the second table, you can see that in the second table, there are two sections. You see, can you see a very, I mean, it's not very distinct, but here is a line. Can you see that? Here is a line here up to the top. Can you see it?
Yes, sir, we can see.
Huh? Hello?
Yes, we can see, sir.
Okay. So you can see that left-hand side of this line, there is one information, Leibniz test for equality of variance. Okay, can you see this?
Yes, sir.
And on the right-hand side, it is the t-test for equality of means. Okay.
Yes, sir.
So therefore, this table actually has two sections. One is providing information about the Leibniz test. Another section is providing information about the t-test. Okay. So Leibniz test is the test which tells us whether the variances in these two groups are same or not. Okay, so as I said earlier, that sig, what does it mean? Sig means
Significance.
P-value, P-value.
P-value. Significance means P-value. So what is the P-value of the Leibniz test?
0.07.
More than
0.074, which is more than 0.05.
Right.
Okay, we said that we shall always compare with 0.05. So it is more than 0.05. That means we cannot reject null hypothesis. Correct? Can we reject null hypothesis?
no. We can reject when it is less than 0.05.
Yes. So can we reject null hypothesis here? No, we cannot. তাহলে আমি বলেছি, I said that null hypothesis always says that the two quantities are equal. That means Leibniz test p-value is telling us that the variances in these two groups are not different in the population. Okay?
Yes, sir.
Have you got it? Am I clear?
So, sir, we cannot reject null hypothesis, so we have to accept the alternate hypothesis. So there is difference, isn't it, sir?
No. What is the null hypothesis?
There is no difference.
So you cannot reject it. So what would be the conclusion?
We'll accept alternate hypothesis.
Why are you going to accept alternate hypothesis once you cannot reject the null?
We cannot reject null. We cannot reject means we have to accept.
Huh?
We cannot reject means we have to accept.
আমি তো আগে তো বলেছি যে
ঠিক আছে স্যার
হ্যাঁ বলেছি যে if we can reject then only we shall consider the alternative.
Yes.
So if we cannot reject the null hypothesis, this means that the variances are same. Okay.
Same.
For simplification, just look at the p-value of the Leibniz test. If this p-value is greater than 0.05, it means that the variances are same. Okay. So if the p-value is greater than 0.05, you can see that the computer has given two t-test values. You see, one is the upper row, another is the lower row. Okay. The question is, which results of which row shall we consider, the upper row or the lower row? Okay. If we look at the left-hand side, it is said that equal variances assumed means variances are equal. And the lower one is equal variances not assumed. Okay, means variances are not equal. Since Leibniz test says that the variances are equal, therefore we shall look at the t-test results of the upper row. Okay. Now we shall check the vary depending on this Leibniz test. Okay. So if we look at the t-test p-value is 0.159, which is greater than 0.05. Okay. That means we cannot reject the null hypothesis. If we cannot reject the null hypothesis, then what shall we conclude? We shall conclude that mean age of diabetic and non-diabetic patients in the population is not different. Okay, is not different. Clear?
Yes, sir.
Clear?
Yes, sir.
If the Leibniz test p-value is less than 0.05, then consider this p-value, 0.20. Okay? Am I clear?
Yes, sir.
Okay. So this is the p-value, t-test, independent samples t-test. This is the mean difference. You can see that the mean of age among diabetics is 27.9, and those who do not have diabetes, it is 26.1. So 27 minus 26.1 is equal to this one, okay? And this is the 95% confidence interval of the mean difference, this one. Okay.
Yes, sir.
So independent sample status. Now, can you do the t-test? Suppose now I am interested to know whether mean systolic blood pressure among males and females is same or not. Mean systolic blood pressure among males and females. Is same or not? Can you do this?
Trying, sir.
Okay, do it. Please do this.
Sir, here both are categorical variable.
Why?
Sex is a string variable and systolic blood pressure. Oh, this is okay, sir.
Please do it. Once it is done, please let me know. Done. Done or not? Done? Not yet. Hello.
Sir,
Ah,
to analyze, then compare means, then
correct.
independent
You
test.
do it. If you cannot, I will do.
Okay, sir, help us.
Done, everybody.
সরি স্যার পারতেছি না।
Okay. And why don't you look at the book? Page number, I tell you. Page number. Page number 8.2. Page number 63, 8.2. To go to page number 64. So you will get the commands. Page 64. Okay. So nobody could do it. Nobody could do it or not.
Sir, can you define groups কি হবে?
Anybody could do it. কেউ করতে পারে নাই। এই বলে কি? কি কেউ করতে পারেন না? So please respond to my question so that I can proceed.
স্পিসেসটা কাজ করছে না, এই জন্য একটু সমস্যা হচ্ছে।
ওকে, কাজ করবে, আমি করলেই কাজ করবে, নো সমস্যা নেই। Anybody else? আর কিছু? আর কিছু? Anybody? Dr. Uma, could you do this? Dr. NC?
Yes, sir.
Have you done this?
Yeah, I'm doing.
Oh, still? No.
Yeah.
It should not take more than a minute.
Sorry, sir.
Okay. So should I do it or not?
Yeah, it's done.
Done? Okay, fine. It's very simple. Okay. So before doing this t-test, as I said that we shall have to check the code numbers. So if we check the code numbers of sex, it is F for female, M for male, and both are in lowercase. Okay, both are in lowercase. So remember this. So it's very simple. Go to analyze, compare means. Let me reset it. Okay, compare means. Then select systolic blood pressure. Push it into the dependent list. Select sex. Push it in level box. Oh, I'm so I'm in the wrong place, I think. So analyze, compare means independent sample status. Okay, independent sample status. So let me reset it. So reset, then select systolic blood pressure, push it into the test variables box, select sex, push it into the grouping variables box. So can you see what I am doing? Hello?
Yes, sir.
Okay.
Yes, sir.
Now click on define groups. Okay. So in group 1, you can write either male or female. Okay, let me write male. Then group 2, F, M and F. You should not write male. You should write the code numbers on M and F. Since the code numbers are in lowercase, so I have used the lowercase. Okay? Clear? Clear?
Yes, sir.
Continue, then okay. Continue, then so you will get it. So the results are there. Results are here. Okay? Can you see it?
Sir.
Yes, sir.
Have you got the results now?
Yes, sir.
Yes, sir.
Okay. Now, can you decide which t-test you will be using from the results?
Yes, sir. And the equal variance is not assumed.
Very good. You just say that lawyer rule. That's all. Thank you very much.
Thank you,
Okay.
sir.
Because the p-value of Leibniz test is less than 0.05. Therefore, we shall consider the t-test of lawyer row. Okay, t-test of the lawyer. Fine. Still, the t-test of the lawyer row p-value is 0.06, more than 0.05. We cannot reject the null hypothesis. Therefore, we say that the mean systolic blood pressure of males and females are not different. Clear? Clear?
Sir, interpretation টা আরেকবার বলুন স্যার। কোনটা
দুইটা-
accept করব এটা বুঝতে পেরেছি, equal balance not assumed এটা আমরা accept করব, কিন্তু তারপর কি বললেন স্যার?
দুইটার blood pressure, mean blood pressure is not different. Same. Okay. এই দুইটা গ্রুপের mean blood pressure answer is same, not different. Okay?
স্যার সেটা কেন স্যার? এখানে তো আমরা বললাম যে p ভ্যালু লেস দেন 0.05 মানে হচ্ছে আমরা
এটা তো লেস দেন 0.05 হয় নাই তো।
ও আচ্ছা আচ্ছা, এবার বুঝছি, এবার বুঝছি। মানে আমি যেহেতু এটা এক্সপেক্ট করব, এটাই আমি দেখব। ফাইনালি
ঠিক আছে, ফাইন। Now let us go to this situation. Let us go to, so third one, whether the training program is effective or not. Okay, let us see whether our training program is effective or not. In our data, there are two variables, pre-test and post-test. We shall use those two variables for testing the hypothesis. So it's very simple. Can you do this? Go to page number. Go to page number 67. Okay, 66, 67. Can you do this? Looking at the book, can you please try? Page number 66, 67. Okay, please try it. So I will give you only 1 minute.
স্যার কোশ্চেন একটু বলেন না স্যার, আমরা পেয়ার টেস্ট করব কিন্তু কোন ভ্যারিয়েবলের কথা বলেছেন স্যার?
Pre-test, শুনেন প্লিজ, pre-test, post-test. Pre-test, post-test. দুইটা ইউজ করব। করা হয়েছে। Done. Why not done?
Yes, sir.
হয়েছে?
হয়েছে।
Oh, very good. So if I do it, go to analyze, compare means I will select paired sample test, okay? Okay. So those who could not do, just follow me. Click on paired samples test. Click karen. Done. So I have clicked. So in our data set, as I said, there are two variables, pre-test and post-test. So you can select both the variables together, or you can push the variables one after another. Okay. So I have selected post-test, push it into the variable one, and select the post-test and push it into the variable 2. Okay? Okay, can you see? Do you see my computer?
Yes, sir.
Okay. Then you can just click on options. Options, we don't need to do anything. Okay. Fine. Then click OK. Simply click OK. simply click on OK. So you can see that the computer has given the mean post-test score, which is 90.9, and the mean pre-test score is 53.5. ঠিক আছে না? ঠিক আছে না? Can you see this one? Huh?
Yes, sir.
Okay. So it has also given the standard deviation. Okay. So this second table is not important to us. We shall look at the third table. And as I said, our main interest is in the p-value. Main interest is in the p-value, which is given in the last column. Okay. What is the p-value? P-value kato? What is the p-value of this test?
0.0.
What is the p-value?
0.000.
0.000. So the p-value is less than 0.05, right? So we shall reject the null hypothesis. What was the null hypothesis here? Can anybody tell me what would be the null hypothesis here?
There is no difference between the mean of the pre-test and post-test.
Very good. The mean score of pre-test and post-test is equal, or there is no difference, right? And alternative hypothesis is the mean score of pre-test and post-test is different. So since p-value is less than 0.05, we shall reject the null hypothesis. This indicates that the pre-test and post-test scores are different, correct? Right?
Yes, sir.
So if we look at the mean, we can see that the post-test score mean is higher than the pre-test score mean. Am I right?
Yes, sir.
Therefore, we can also say that the post-test score is significantly higher than the pre-test score. Okay? The mean post-test score is significantly higher than the mean pre-test score. Okay, am I clear?
Yes, sir.
Okay. Any question from anybody? Any question from anybody?
Sir.
বলেন।
হাইপোথিসিস টেস্টিং এ যদি এরকম হয় যে জানতে চাই প্রথমে যে এটা কি এটার চেয়ে বড় অথবা ছোট কিনা, হ্যাঁ, ইন দ্যাট কেসও কি আমাদের নাল হাইপোথিসিস হবে যে সেটা ইকুয়াল?
আচ্ছা, I think it's a good question. Do you have any idea about one-tail test, two-tail test? You see, the computer is giving us two-tail test. খেয়াল করেছেন? Have you marked it? See, within the bracket, it is written two-tail test. Correct? Okay. Now let me come to your question. Okay. So let me come here. Come to your question. So you want to say that, suppose you want to prove that, if I say proof or hypothesize that the post-test score mean, I mean the mean post-test score will be greater than pre-test, correct?
Yes, sir.
Okay. In that case, remember that in the null hypothesis, equal should always be included in the null hypothesis. Therefore, the null hypothesis would say that post-test score, post-test, I'm not writing the full, is either less than or equal to pre-test score. Okay, am I clear now? Am I clear now? So this is a situation we call one-tail test, okay? One-tail test. But the hypothesis that we have tested so far, here the null hypothesis is pre-test, is post-test, post equal to pre. Alternative hypothesis that we have tested says that post is not equal to pre-test score. Okay? Exactly. It may be less than this or more than this. That's why it is a situation where we test the hypothesis as two-tailed test. Okay?
Sir.
Okay, am I clear?
Yes, sir.
But in reality, we commonly consider the two-tailed test. ঠিক আছে? Am I clear?
স্যার মানে এই টেস্টটা দিয়ে করা হবে, শুধু আমাদের সেট করার সময় ওভাবে সেট করতে হবে, এটাই তো না স্যার?
The thing is that we shall consider the two-tailed p-value. In SPSS, it does not give the one-tailed p-value. ঠিক আছে? But if you use stata gives one-tailed p-value and two-tailed p-value. Okay? But don't worry, commonly we consider the two-tailed p-value, and we prefer to have the null and alternative hypothesis as two-tailed hypothesis. Am I clear?
Yes, sir. কিন্তু সেক্ষেত্রে স্যার যদি আমরা ইনফারেন্সিয়াল যে কনক্লুশন আনতে চাই, হ্যাঁ, সেক্ষেত্রে আমরা কিভাবে সেটা ওটাকে লিংক আপ করব? যে
Okay, say I will here, for example, you can say that pre-test and post-test are different, correct? Since it is statistically significant, correct?
Yes, sir.
Am I clear?
Yes, sir.
But it is better to say what you have said right now. It is better to say that because I can see the mean. If the test is significant, it indicates that the pre-test score is significantly higher than post-test score is significantly higher than the pre-test score. And if you conclude it like this, it is much better. It is more meaningful. Am I clear?
Yes, sir.
ঠিক আছে?
Yes, sir.
But in that case, you shall have to check these mean values. Okay? Clear?
Yes, sir.
Okay. Any other question from anybody else? Any other question from anybody else?
হাইপোথিসিস টেস্টিং এর উপর আরো আছে, তাই না স্যার?
এটা মাত্র শুরু হলো। Okay. Now let us see the third hypothesis that we wanted to check. This one. Okay. what we said is that whether the mean income of all the religious groups is same or not. And we said that we agreed that to test this hypothesis, we shall use one-way ANOVA, okay? So let us see how to use it. Very simple, very simple. Go to Analyze, Compare Means, just select one-way ANOVA. Okay, select one-way ANOVA. Okay. Click on one-way ANOVA. Click on one-way ANOVA. Click করেছেন? Okay. Now select income for the dependent list box. Okay. Income for the dependent list box is very simple. And select religion for the factor box. Select religion for the factor box. Okay. Okay. Done so far?
Yes, sir.
Okay. Click on options. Options. Click on options. Options. Click on done. Have you done? Have you clicked on options?
Yes, sir.
Options. Select descriptive. Select descriptive. Select homogeneity of variance test. These two. Okay. Descriptive, homogeneity of variance test. Have you selected these two?
Yes, sir.
And if you want the plot, you can, it's optional, up to you. Means plot. You can also select the means plot to see graphically the mean income of the religious groups. Okay? Okay?
Yes, sir.
Okay. Continue then, okay. Continue then, okay. Continue, okay. Done. Done. Okay. So have you got the results, everybody? Can you see my computer as well?
Yes, sir.
So you can see that in our religion, there are 4 groups: Muslim, Hindu, Christian, and Buddhism. And there are 126 Muslims, and number of Hindus and other religions are shown in the table. Can you see everything, right? You can see everything. Can you see? The number of Hindus is 36, Christian 26, Buddhist 22. Clear?
Yes, sir.
Okay. So you can see that the computer has given the mean income of Muslims, Hindus, Christians, and other religions. Okay. This is the mean income of the Muslims, Hindus, Christian, and Buddhist. You can also get the standard deviation, 95% confidence intervals, okay? That means you can see the descriptive statistics of income by religious groups. Clear?
Yes, sir.
Is it okay? Clear?
Yes, sir.
Okay. So like the t-test, we shall have to do the homogeneity of variances. That means whether the variances of income of Muslims, Hindus, Christian, and Buddhists are same or not. Again, the computer has done the Leibniz test that we have seen while using the t-test, okay, Leibniz test. Our interest is in the p-value, significance, okay? The computer has given several p-values, okay? You can see. You may take the p-value of the calculation, which is based on median, or you can also take the p-value, which is calculated based on mean. You can take either of these two. Okay, so you can see that the p-values are greater than 0.05. ঠিক আছে না? Am I clear?
Yes, sir. Yes, sir.
That means that the variances are not different. Variances are equal. Okay? Okay? Am I clear? Like before, like the t-test. Variances are equal. Okay? Clear?
Yes, sir.
Okay. If the variances are not equal, that is, if the p-value is less than 0.05, then ANOVA test result is not valid. Okay? If the p-values are less than 0.05, this ANOVA test is not valid. We shall have to use some other test. Okay?
Yes, sir.
Since the p-values are greater than 0.05, so ANOVA test is valid. So again, we shall look at the p-value. P-value is how much?
Less than 0.05.
So p-value is less than 0.05. That means we shall reject the null hypothesis. So yes, we conclude that the mean income of all the religious groups are not same. Okay? The yes, mean income of all the religious groups are not the same. Okay, am I clear?
Yes, sir.
So,
হোমোজেনিটির সাথে কিভাবে কি বললেন এটা?
ওটা হলো হোমোজেনিটি অফ ভেরিয়েন্স। ওই যে আমরা টি টেস্টে করেছি না, লেভিনিজ টেস্ট। It is the same thing, but computer, we need to do this for ANOVA as well.
ANOVA-কে আমরা অ্যাকসেপ্ট করব কিনা সেটা দেখার জন্য আমরা টেস্ট অফ হোমোজেনিটি করব। সেখানে যদি সিগনিফিক্যান্ট থাকে তখন আমরা ANOVA ইন্টারপ্রিটেশনটা দেখব। আর যদি সিগনিফিক্যান্ট না থাকে তখন স্যার?
If not significant, then we shall use ANOVA.
Not significant? Not significant. Here, sir, test of homogeneity is significant. We are saying that it's significant.
Why do you call it significant? Is it less than 0.05? It's not less than 0.05. So you cannot say that it is significant.
Okay, sir.
Okay. So if it is less than 0, I told you earlier that if it is less than 0.05, we call it significant. Let me check. You see, this is what we call significant, okay? If it is less than 0.05, we call it significant. Fine. So we can, so the Leibniz test p-value is greater than 0.05. That means it's not significant. If it is not significant, then we can consider the ANOVA test. If it is significant, then we cannot consider ANOVA test. Clear?
Okay, sir.
So since the Leibniz test is not significant, we shall use the ANOVA test. And the ANOVA test p-value is 0.01, which is less than 0.05. That means we shall reject the null hypothesis. This indicates that the mean income of all the religious groups is not the same. Okay? Mean income of all the religious groups is not the same. Clear? Clear?
Yes, sir.
Huh? Is it okay or not?
Okay, sir.
Fine. Now, the problem is that we said that the mean income of all the religious groups are not same. But the ANOVA test does not tell us which group means are different, okay? Whether the mean income of Muslim and Hindus are different, or Hindu and Christian is different, or Christian and Buddhist is different, or Muslim and Buddhist is different. The computer does not give it, okay? The F test or the ANOVA test does not give this. ঠিক আছে না? আমরা তো দেখতে পাচ্ছি না. Can we see this? Can we see this?
Sir, no.
We cannot see this. To understand which group means are different, we shall have to use another statistic. Okay? Am I clear? To understand which group means are different, we shall have to use another test. We call it post hoc test. Post hoc test. Go to analyze, same place. Go to analyze, compare means, one way ANOVA. Okay? So come here. Everything is there. No problem. You can see there is one post hoc tab. Okay? Can you see it? Post hoc tab.
Yes, sir.
Yes, sir.
Click on post hoc. Click on post hoc. Click. Click on post hoc. Click. Now, from here, you select Bonferroni. Here, you can see that Bonferroni. Select Bonferroni. Okay. Have you done it?
Yes, sir.
You can also select Tukey. Tukey test, Tukey test, Siddharth. There are many options, but commonly we use Bonferroni. Okay. You can also use Tukey. So select Bonferroni, continue, okay, continue, okay. Done. Have you done it? Have you done it? Done? কি করেছেন?
Yes, sir.
Okay. You can see that the computer has given an additional table now. So these tables we have seen earlier. Okay, these three tables we have seen earlier. Now this is the additional table the computer has given. Look at the p-value, okay? Where the p-value is less than 0.05, here, okay, here, right? You can see it here. Can you see it?
Yes, sir.
So p-value is less than 0.05. And where else? It is also here, right? 0.05, correct?
Yes.
Huh?
Yes, sir.
Okay. Now, if we look at the left-hand side, so this p-value is significant for whom? For the difference of mean income between Muslim and Hindu. Okay. So this indicates that the mean income of Muslims and Hindus are actually different. Okay. Mean income of religious groups are not statistically different. Clear? So okay, so it is all right. Now again, you can understand who has greater mean income. So look at the descriptive statistics. You can see that mean income for Muslims is 88,000 something, and Hindus has 79,000. So Muslims have higher income, significantly higher income compared to the income of Hindus. Okay, am I clear?
Yes, sir.
Okay, so remember that we need this post hoc test if ANOVA test is significant, okay? If it is not significant, actually we don't need this post hoc test. Clear? Because all the mean of all the religious groups are same. Therefore, we don't need to have the post hoc test. So post hoc test is needed only if the ANOVA test is statistically significant. Am I clear?
মানে প্রথমে ANOVA দিয়ে আমরা জেনারেল কমেন্টটা পেয়ে যাব যে ডিফারেন্স নাই তাহলে আমাদের পোস্টে যেতে হবে না
Absolutely. Looking at the ANOVA, you will decide whether post hoc test is necessary or not. Okay.
Yes.
Fine. So I think it's already about quarter to 10. So let us finish up to here because we have discussed many things today. So far, yes.
স্যার এখানে আমাদের মাল্টিপল কম্পারিজন মানে অ্যানোভাতে যদি একটা সিঙ্গুলার গ্রুপের সাথেও যদি সিগনিফিক্যান্ট ইয়ে থাকে আপনার ডিফারেন্স থাকে তাহলে তো সিগনিফিক্যান্ট চলে আসবে অন্যগুলোতে যদি সিগনিফিক্যান্ট নাও থাকে ইন দ্যাট কেস তো পোস্ট হক করাটা একবারে মানে জরুরি হয়ে যায় যে না ঘটনাটা কি দেখার জন্য
Exactly. Therefore I said that whenever this p-value is significant, come on, যখনই ANOVA রেজাল্টটা সিগনিফিক্যান্ট হবে তখনই আমার পোস্ট হক টেস্ট করতে হয়, ঠিক আছে? But if it is not significant, we don't need the post hoc test. Clear what you say?
Yes, sir. Yes, sir.
Okay, very good. Very good. Any other question from Uma, Dr. Uma? Dr. NC? Dr. Manisha? Dr. Faisal? Mustafa? Nobody has any question? Let me stop presentation. So, anybody has any question? Nothing, no question. I don't know why everybody is very silent today. What happened? Dr. NC, are you here?
Yes, sir. So far, so good. No doubt.
So have you understood what I have said?
Yeah, so.
Is it okay? Can you do it?
I think so. I can.
Okay. So, I mean, you see, there are two important things. Number one is how to decide what statistic shall I use. Another important issue is how shall I interpret the results. So these are two important things. Okay.
Okay.
So interpretations, everything is written in the book. And how to decide, it is also written in the book, chapter 7, in the table 7.1. Okay.
Okay.
So please try, everybody please try at home. And if you face any problem, we shall again discuss in the next class, in the next session. Okay.
Okay, so.
Okay, sir. Thank you,
Okay,
sir.
fine.
Assalamu alaikum.
Okay, fine.
Assalamualaikum, sir.
Okay,
Assalamualaikum,
so,
sir.
okay, thank you then. Thank you, everybody.
Thank you, sir. Assalamualaikum.
Thank you.
Thank you, sir.
Thank you. Thank you. Bye. কিবরিয়া কি আছেন? কিবরিয়া কি আছেন? আফরোজার খবর কি? আফরোজা, আপনি কেমন আছেন?
জি স্যার, আলহামদুলিল্লাহ ভালো আছি। স্যার আপনি ভালো আছেন?
হ্যাঁ, এই তো ভালো। আপনি বুঝতে পারতেছেন তো?
স্যার আজকে একটু কঠিন লাগছে আমার, আমি আজকে একটু স্লোলি ধরতে পারছি, তবে স্যার রেকর্ডিং আছে তো আবার বাসায় ট্রাই করবো স্যার।
ওকে ওকে, এখন তো স্ট্যাটিস্টিক শুরু হয়েছে তো, যার জন্য একটু কঠিন, কেমন একটু কঠিন, বাট এনিওয়ে পারা যাবে, ঠিক আছে।
জি স্যার। আর স্যার লাস্ট দিনের ওই ডায়াস্টোলিক ব্লাড প্রেশারটা মেল আর ফিমেলে বের করাটা, এটা আমার কাছে কঠিন লাগছে, বাকিগুলো স্যার বুঝছিলাম।
ওকে, ওই যে রেকর্ডটা দেখে নিয়েন, না পারলে বলেন নেক্সট
জি
ক্লাসে
জি
আবার
জি
বলে দিব।
জি স্যার, অবশ্যই স্যার। ওকে স্যার, থ্যাংক ইউ সো মাচ স্যার। আসসালামু আলাইকুম।
থ্যাংক ইউ, ওয়েলকাম, সালাম, থ্যাংক ইউ। Kibria has left.